BuildIT has a new command called reduce cloud that greatly increases the efficiency of cloud processing for tolerance analysis, which involves best fits and deviation plots. We will look at the various methods' strengths and provide insight into the correct application. The cloud reduction command is available in Edit, Point Cloud, Reduce. There are three methods available: simple sampling, distance sampling, and tolerance sampling. We will demonstrate the command on this cloud, which has noise and outliers. The first method is simple sampling, which is a quick way of reducing a cloud. It simply keeps a fraction of the points. The selection of points that are kept is only dependent on a points order in the internal representation of the cloud, typically the order with which the points were recorded, and there is no way to guarantee that the resulting cloud will have a uniform density. Simple sampling is best suited for extremely large clouds where the input cloud is well conditioned, meaning that its spatial distribution is coherent, with minimal overlap, low noise, and little outliers. The second method is distance sampling, which preserves 1 point per area. As you can see, it provides more coverage, but it does not affect noise or outliers. This method is the jack of all trades. While it may not be the best for outlier and noise removal, it is reliable and requires no particular tuning of its parameters and has no negative side effects. Distance sampling has the option of averaging the points in an area. The fact that it doesn't preserve the original points makes this option less suited for tolerance analysis because it can produce false negatives or false positives. However, this is good for reverse engineering applications where we are looking to extract the design intent more than the actual deviations of the manufactured part. Finally, we have tolerance sampling, which is the most powerful reduction method. It not only keeps a point per area, but it also tries to select the point that best represents the local trend, thus eliminating outliers. We simply need to select an area as well as a tolerance zone. It should be thick enough to include the noise while being thin enough to exclude outliers. This method has excellent coverage preservation, just like distance sampling. It preserves the original, most representative points and explicitly aims to distinguish between inliers and outliers in order to reject the latter. Its only drawback is that it does require some basic knowledge regarding the method and conditions of measurement in order to properly set the tolerance value to target outliers. Looking at the various reduction methods, we have discussed their strengths and where they break down, providing insight into their correct application.